Hello and welcome to this short presentation on EngineRoom software. My name's Chris Dunham. I'm the Managing Director of Carbon Descent. What I'm going to do is just take you through a short presentation and then show you the software itself. So a bit of background about us. Carbon Descent were started 14 years ago. We're a company that produces both software and sales consultancy. EngineRoom is one of 4 software products that we sell. And hopefully, as the name suggests, Carbon Descent, we're about reducing carbon emissions. A bit of background about EngineRoom. It was developed by us through a KTP with London South Bank University. We used it over a number of years extensively in-house to model CHP feasibility before deciding to sell it on the open market as a commercial piece of software. The advantages are that it's robust and flexible, but it's very, very quick to get to an answer on the optimal size of CHP for a scheme, and indeed whether CHP and community heating will be viable at all for that scheme. The cost is £2,500 for up to 3 users as an initial fee, and then there's an ongoing fee of £1,000 a year, which covers support and updates and upgrades, and those figures are excluding VAT. Right, I'm now going to switch over to the software itself. As you can see, there are 5 steps here that you need to go through before you can press calculate and get some answers. So, first step, generate some load profiles. The approach we've taken in EngineRoom is that we're trying to generate profiles for a typical day, hourly profiles for a typical day in each month of the year. So, the first way to do that is the most technical option, which is here to choose between different building types. Then enter details about floor area, occupancy hours, base temperatures, air infiltration, U values and areas. So all of this is about generating the thermal demand profiles. And then down here, information to generate electrical demand profiles. So for instance, you can choose air conditioning and estimate demand profiles. And there you can see we've got our profiles for this building type. We can say we want to use those. Another option is to use benchmark values in kilowatt hours per square meter per year for different building types. So if we had no idea about the demands for the building, but we wanted to use those sort of typical values, and then we can adjust those based on occupancy times, base loads, and so on, and which will then, using typical profiles of demand for those types of buildings, generate our hourly profiles. So that's the second way you can do it. The third way is you can actually enter fuel consumption data, and you can do that on a yearly basis and it will generate profiles, or on a monthly basis, or if you actually have the hourly figures already, which you might have generated from another piece of software, or you might have real monitored data that you can put in, then you can simply copy and paste them in here. So those are our load profiles. Second step, tariffs. So 2 distinct approaches that you can take with EngineRoom. One is that the owner of the plant is also the owner of the building and responsible for paying the bills. So in that situation, they're offsetting costs that they would have had to pay themselves for imported electricity and gas. And the other approach is an ESCO approach, where you're selling electricity and heat. So here you can model those heat and electricity prices and charges associated with that. But you're then responsible for buying in electricity, top up and standby, and exporting electricity in the same way that the owner would have been. And here you can see you can model different types of tariffs, so a seasonal time of day tariff, or a sort of day-night tariff, or just a flat rate tariff. So that's energy tariffs. Moving on to the third step, choosing our CHP plant that we want to conduct the modeling for. So here you can see I've already selected some. So EngineRoom comes preloaded with a database of engines and information about their part load efficiencies, capital costs, maintenance costs, and so on. You can edit that database and change those values and add your own engines if you wish. Here you can see that we have different control strategy options. So typically people are choosing heat-led or power-led, so you can switch between those different options. And here you can specify the run times for the plant. You can either specify times or let EngineRoom decide for you based on the technical parameters of the engines you've selected. So that's the third step. Fourth step, financial information. So as you'll see, we get MPV, and internal rate of return, out of this. So it needs to know project life, discount rate, inflation, and so on. Here you can model CCL and any other subsidies that might be relevant. Here you can model tax and depreciation, finance, and any loans, capital costs in more detail through this section, and you can do that in two ways. So the first is based on percentage of CHP, so you can put it in as a percentage of the engine cost, or you can put it in as we have down here. I've already put this in just as an example. I filled in one row. I've put in £500,000 for the network here. But depending on what sort of stage you're at in the feasibility, you might have very detailed information about these specific items that you want to put in. So that's cost information. Finally, fifth and final step, to model the emissions, and here you need to choose your emissions factors for CO2, and down here, if you wish, you can model other environmental emissions, NOx, SOx, carbon monoxide, particulates can be modeled there. So you can also save what you've entered and reopen that for another time. But we've entered the information we need now, so press calculate, and you'll see very quickly we get a comparison here in terms of net present value between the different engine sizes that we selected here, from 100 kilowatts electrical up to 378. So the engines we selected. So you can see for MPV 210 looks good. Internal rate of return slightly different. CO2 savings different again, as is often the case. A larger engine would give you better CO2 savings. So we might have decided now that our 210 kilowatt engine looks interesting. So let's go back and say we want to analyze that engine in more detail. Let's have a look at it and press OK and recalculate. And here we can now see we can scroll through different months in the year and look at what EngineRoom is assuming the pattern of generation against those demand profiles for power and heat for those typical days in each month. Here we can see net present value happily improving over our 25-year project lifetime that we assumed, and here you can see more technical information about the operation of the plant, the summary of sort of financial figures here, the CHP unit information, its actual performance in terms of run hours, heat utilization, its QI, emission savings. EngineRoom calculates savings against a base case. That's the approach. You don't need to compare two different project files. It assumes a base case of boiler plant, and you're putting in CHP and calculates savings against that base case. So here you can see the financial appraisal in more detail over the 25-year project life that we chose, and how that MPV and internal rate of return are calculated. So that, in a nutshell, is EngineRoom. Thank you very much for listening.